don't know. I think that's a little bit too young. Okay. You took maths at 8? Extra maths?
5.
Huh?
She's making a 5.
Nice. Is this like after school? Extra classes? Yeah. No, but it's different if you do an after school thing. That's different to the student needs help because they're having problems, you know. Like after school it's like extracurricular. Alright, let's see. Mechanics? No. Physics? Mechanics? Newton? Okay. There we go. Okay. There we go. You can write that down. We'll get started.
So do you have you today for assessment support?
No, I don't do that assessment support. I would only ever do the morning one, which is like Wednesday or Thursday.
So today's
Yeah. I'm not 100% sure if I'm doing it this week. I think I might, but I need you to bring your laptops to it. So I don't know if you all have laptops. Do you?
Mm-hmm.
Yeah? Okay. Right. Force, Newton's second law. You got that? Yep. Okay. It's not too difficult today to start with. Some basic formulas to look at. So we all understand the word force. I mean, we know it from English. But what exactly is it? So if I say the word force, what would you say that is? If you were to give it another word or meaning. Go on, what are you thinking? No, are you sure? Okay. Just in English, what would force mean?
Force? There's no other word.
Force means force. True. Huh? Yeah, but like just general English, like what would a force be? It's like a type of power, isn't it? Like a strength, you know? Not this though, not this force for sure. Okay, anyways, what exactly is force in physics? So force has a physics definition, a precise physics definition, and we say force is what changes the motion of an object. That is, force will change either. Okay, so force does two things. It changes either the direction or the speed. Or it could actually change both. So force is what changes the speed or direction, or possibly both. In other words, force causes an object to accelerate. Now, I think just that sentence will be enough. The rest is just for extra understanding. So, in other words, force causes an object to accelerate. Although forces can have other effects, such as changing the temperature or shape of an object. So, a force can also do other things too, like change the temperature or the shape of something. You know, if I squeeze this, I can change its shape. Well, maybe not that. But, it's true to say that if an object is accelerating, then a force is being applied. That's the key point here. If an object is accelerating, then a force is being applied. You should write that down. That's like the key point here. If I see something accelerating, then I can say there's a force on it. Yeah. And finally, force is a vector. Okay. Now, next. How do we measure force? So does anyone know the units? I think you do. Oh yeah, that's the formula, but the unit for force. Newton, yeah. So force is measured in newtons, and the letter, of course, is N. Does anyone know what the definition of a newton of force is? Like, how much force is a newton of force? Anyone know this one? Like, how big is a newton? So, we say a newton of force is the amount of force required to accelerate a kilogram by a meter per second squared. That's what 1 newton will do. 1 newton will take 1 kilogram and give it an acceleration of 1 meter per second squared. That's what a newton will do. Okay. This definition is actually very common in the exam. I've seen it, 3-4 times now. What is a newton? So it's pretty common. That's probably chow, is it? Hey, come on in. What happened to you? Not feel well? We're a couple of slides in. You'll have to catch up later. Okay. Got that? Yeah? Okay. So, the definition could be asked in the exam. So, learn it off perfectly because I've seen it a few times. Okay. So, there is a relationship between force and acceleration, and a couple of you said it already, and it's given by what's called Newton's second law. So, I think we all actually know this one. There's 3 laws in total, which we'll look at in time. One way to state his law is F equals ma, which I heard at least 2 or 3 people say this already. So, if we know the mass and the acceleration, we can know the force. Yeah? F is the force, m is the mass, and a is the acceleration. Now, in fact, you can state Newton's second law in other ways, but again, we'll look at that later. Here's something interesting too. What unit is the left here? Newton. And what unit is the right? Kilogram meters per second squared. So that actually means 1 Newton is the same as 1 kilogram meter per second squared. So you actually have a choice. You can actually say, something like force equals 1 Newton, or force equals 1 kilogram meter per second squared. So this is why remember we had the 7 basic units. The reason Newton is not part of the 7 basic is because it's not necessary, because Newton is the same as this, kilogram meter per second squared, which they are part of it. So this is why Newton's not included in the base 7, because it's not actually a special basic unit, because you can write it as 3 basic units. Okay, so F equals ma. Make sure you write that down. Got that? Yeah? Yeah? Okay. Here is a very simple question. I think you can all do it. I'll give you a minute to try it. Maybe you can even do it in your head. A 45 kilogram girl starts to run from rest with an acceleration of 2 meters per second squared. What force is she applying in order to accelerate? 90 newtons, yeah, because F equals ma. 45 multiplied 2, okay. Right, now here's one maybe not to do in your head. You see a barista, the person who makes your coffee, slides a coffee cup This can be our coffee cup because it actually has coffee in it. Slides the coffee cup across the table. So initially it's at rest, and he pushes it, and it leaves his hand at 30 centimeters a second. And he seems to be touching it for 1 second, so he only touches it for 1 second. Okay, and when it leaves his hand, it's going at 30. And you would think the mass is about 500 grams. How much force was in his hand when he pushed it for 1 second? No, that's getting a bit harder. So I'll let you try it before I do it. I want to see if you can figure out how to do it. So I'll give you one clue. You, of course, have to use F equals ma, but you will also have to use UVATS equations. And one more clue, of course you have to convert centimeters and grams. Okay, see what you can do. Think deeply about it. Sounds believable. Shall we check? Well, let's just give other people a minute because I see some people are nearly finished. Are you confident of this answer? No, be confident. You've got answers? Same as his?
Yeah.
Okay, it's looking good. It's looking good. Let's have a look. So, let's write down our info. We know the U. What's the U? 0. Meters per second, to be clear. And V is 0.3 meters per second. And the A we don't know, and the T we do know. 1 second. And the S we don't know. How can I get the A? Well, I can say V equals U plus AT. So A equals V minus U over T, which is 0.3 minus 0 over 1, which is 0.3. That's the A. Right? But F equals MA, which equals 0.5, that's the 500 grams, times 0.3, which equals 0.15 newtons. So not too bad. What do we think? Is it okay? Yeah. Did you get it, or did you need to see it?
No, I was doing it, but I didn't get the final answer.
You needed a little bit more time. Yeah. I think I'm going to add a second question to this. I'm going to make it a two-part question. Can I scroll down? Yeah? Yeah? I'm going to make it a part two. So that was part one. Now here's part two. So there's the table. And there's the coffee cup. And it's going to the left. Well, no. Let's make it Western. It's going to the right at 30 centimeters per second. Okay. Now, will it continue at this speed forever?
Stop.
Yeah, it'll stop. But why does it stop?
It's decelerate.
Very good. Yeah. So eventually, it'll come to rest. Okay? And let's say, let's try and use our imagination. What distance do we think that might be? You push a coffee cup across the table. How far would it travel, do you think? Come on, use your imagination. Give me a distance.
1 meter.
1 meter?
Yeah.
Okay, 1 meter. Why not? No, let's make it more interesting. Let's say 90 centimeters. How about that? Okay. So you said it stops because it decelerates. In fact, what's happening as it's sliding across, there's a force pushing it back.
Friction.
Yeah, friction force. There's a force here. It's called the friction force, and we'll actually talk about that more today. So, as a small question, I want you to do is to calculate F now. Actually, let me just make sure I haven't actually done that second question. No, I haven't. Okay. Calculate F now. Give that a try. I hope I gave you enough information to solve this. I think I did. Okay, ready? Right, so I think this is okay. It's kind of similar to the last one. Come on, stuck. F equals ma, which equals 0.5a. So we have to find the a again. So the u is 0.3, the v is 0, the a we don't know, the t we don't know, the s we do know. It's 0.9. What will give us the a? S equals? No. V squared equals? V squared equals u squared plus 2as. So the a is minus 0.3 squared over 1.8. What's that, please? Negative 20? What did you say, sorry? What's this? Can you type it in, please? Minus 0.3 squared over 1.8. 0.05. Negative 0.05. Okay, now if you just put that in here for a, you'll get your answer is minus 0.025 newtons. And why is it negative? Yeah. Okay. Is that okay? Yeah. One more example. Yeah. A 1,200 kilogram car is traveling at 100 kilometers an hour on the motorway. The driver suddenly brakes. B-R-A-K-E-S, isn't it? Not B-R-E-A-K-E-S. That's the wrong brakes there. Bad English. Brakes. Brakes. Yeah. There's two brakes. There's the brake with the car and brake like this. And the car screeches to a halt. That means it suddenly stops. But it took 100 meters to stop. So how much force are the... Oh, for goodness sake. How much force are the brakes applying in order to bring the car to rest? So this is like my last example with the coffee cup, okay? The car is going 100 kilometers an hour, and then it suddenly stops in 100 meters. So there was a lot of force to make it stop. So I want to know how much is this force. Okay, so it's very similar to the last example. There you go. How much force are the brakes applying? Yeah, not going to factorize. Okay, how are we doing on this one? It's okay? We got an answer? Yeah? Shall we have a look? So, similar to the previous one, isn't it? F equals MA. What's the M, did I say? 1200. A. U is, now it's 100 kilometers per hour. Sorry. And the V is 0. The A we don't know, which is what we want. The T we don't know. The S we do know. It's 100 meters, isn't it? By the way, what's 100 in meters per second? 33, is it? 27.78, is it? Meters per second. Okay. So what will give us the A here? V squared? V squared equals U squared plus 2AS. So the A is minus 27.78 squared over 200. Yeah? What is that, by the way? Minus, pretty big number, I think.
Minus 3.85.
3.85? Yeah? Okay, so we just need to put that guy, so multiply that by 1200 and we get our answer.
Minus 4620.
Yeah.
No.
No, that seems right. It should be a pretty big number. Yeah, because you're causing the car to suddenly stop in 100 meters and it's going 100 kilometers an hour and it's 1200 kilograms. So I was expecting the answer to be in the order of thousands. Yeah? I'll give you one more question now. Oh, sorry, do you need to write this down? Yeah. Huh?
I always convert to meters.
Yeah. 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 Okay. Let's add on a second part to make it interesting. So, whoops. Okay. If there was an extra person in the car, physics teacher of mass, let's say 100 kilograms, how long would it take the car to stop? Assume the force is the same. Alright, so I'm adding on a second part here. Yeah. Let's just load it up here. So, there's an extra person in the car now. And this actually makes the car take a longer distance to stop. It doesn't stop in 100 meters. It actually takes a little bit more than 100 meters to stop. The following information is the same. The force is the same. Okay? The mass is not the same. What's the mass now? No? 1,300. The mass is different. So, the acceleration is different. Okay? The U is the same. The V is the same. The S is different. I want to know what the S is now. Okay, let's maybe think about giving you a little bit of help here. So, come on, pen. Right, let's get our info here. The U is still 27.78, right? The V is still 0. The A we don't know, the T we don't know, and the S we don't know. But if you look here, we can know the A, because Newton said F equals ma. So A equals F over m. So the A here is F over m. Yeah? So, what am I looking for? The S. What best gives me the S? The V squared? V squared equals U squared plus 2A S. V squared equals U squared plus 2AS. So finally, the S would be 27.28 squared all over 2 times 4620 over 1300. Now, let's see what that is.
$104.7.
104.7 meters. So that means that was an extra 4.7 meters to stop. Kind of a lot when you think about it. You have one extra person in the car, and it takes nearly 5 meters longer to stop the car because of the increased mass. Okay, got that? Yeah. Alright, so close that there. Right, I'll give you a few minutes to get started on these, and then we'll do the next lesson in 10 minutes. Yeah, you go ahead, yeah. So get started now on the next homework. There's 6 questions there.